Hello, everyone. This is Mobin. I'm a PhD student at UC Santa Cruz, and I'm very glad to present this section to you. In this part, I'll go through the steps that you need to know if you want to use the workflows we have been developing for Human Pangenome project. After this section, you will be able to find the HPRC workflows from Dockstore, import them to a Terra workspace, run the workflows on Terra, and finally receive the outputs of your run. But before going through the workflow and Terra, let me give you a brief description of the assembly workflow. Here you can see it. You can see the inputs, the tools that are being called, and the outputs. The most important input to the workflow is the set of hi-fi reads of the sample that you want to assemble. You also need paternal and maternal short reads. And the reason is that the assembler that we have chosen for producing HPRC assemblies, which is HiFiSM, needs parental information to phase the haplotypes in the assembly graph. But HiFiSM does not take the raw short reads. What it needs is the output of YAC, which is another tool for extracting k-mers specific to each haplotype. After running YAC once for each parental short read, we give the output of YAC along with the hi-fi reads to HiFiSM, and HiFiSM will produce a haplotype resolve assembly graph in GFA format, and then we will pass those GFA files to GFA tools, and it will produce a linear version of assemblies in FASTA format. So that was a brief description of the HiFiSM pipeline, the assembly pipeline. And now I will show you the workspace where you can find a test data set. For finding that, you have to go to the Terra website, which is terra.bio. You have to log in. And then on the left side, you can click on the main menu tab. Your name should appear here. And then you have to click on Workspaces. So it will navigate you to another page where you can see a list of the workspaces you have access to. But to find the workspace that we need now, you have to go to the public tab here and search for Pangenome. And now you will see two workspaces appear here. Both of them are for this for the workshop, but the one that we need now is the assembly one. So I select the first one. So here's the dashboard page where dashboard page of this workspace, where you can find information about why this workspace is created, the data that are imported here, the workflows that are added to this workspace, information about the workflow, the data, and also some potential next steps for people who are interested in doing quality control. But now you have only read access to this workspace. In order to create a copy of this workspace where you can actually add data, edit data, add workflows, and even run workflows, you have to create a copy. To do so, you have to click on this three-dot icon on the right side, and then click on clone. And by cloning, you will create a copy of this workspace. We can write the name of the copy here. I just leave it to be as default, and then I click clone workspace. So I've already cloned it, so it gives me an error, but you can do it if you haven't done that before. So let me go back to my workspaces. You can see that there is copy version of this workspace. So I click on the copied workspace, and now let me show you the data table, which has links to our data set. So click on Data tab, and on the right side you will see a table with the name sample. Here, click on sample, and the table pops up. This table has only one row with multiple columns. Let me iterate over the columns and explain what each column refers to. The first column that we need for assembly workflow is input underline hi-fi, and you can even download it here by clicking on this link, and you can see the download button, and you are even able to use terminal download command, but it requires you to have gsutil installed on your machine. And if you're interested in installing gsutil, there's a link in the dashboard page. But anyway, input hi-fi is one of the input files we need. The other columns, you can see maternal and paternal Illumina data are also available here. And it's worth mentioning that this data is for HC002, but it only has the chromosome 20 reads. So it is just a small test case. After learning how to run the workflow for this small data, you'll be able to run it for any other data also. And there are also some other columns like maternal ID and paternal ID at the end. And there are also some other columns that starts with output underline. These are the output columns that we are going now to produce. And so since we already ran the workflow, you can see the columns here. But now I'll show you how to do it. The next step is to import workflow to this workspace. Since HPRC has released its workflows on Dockstore, you should go to the Dockstore website, dockstore.org, and then you can find the organizations tab on top of the page, and you have to search for organizations here. Let me write HPRC, or you can either write Pangenome, Human Pangenome Reference Consortium, or anything related, and you will see the link to the official HPRC page on Dockstore. Here you can see different collections of workflows that exist here. The one that we need now is under hi-fi assembly workflows. There's only one workflow in this collection, which name is Trio Hi-Fi assembly. And here's the page where you can find different information about the assembly workflow. For example, here's the link to the GitHub repository where this workflow is actually located. And under Files tab, you can find the WDL files that are being used in this workflow and some other information that we skip for now. But on the right side of this page, you can select the environment you want to add this workflow to. The ones that we are interested in are Terra or AnVIL. It doesn't matter, you can select either of them. Let's click on AnVIL. And so you need to input the destination workspace here. So I search again for Pangenome, and the one that I just cloned is this one, Pangenome assembly copy. I click on it, and then I should click on import, but now it gives me error because this trio high-firism assembly is already imported to that workspace. So let's go back to the workspace. Now we should go to the workflows tab. And here you can see that trio high-firism assembly workflow is already imported. So I click on it. Now we have almost everything set up. The data table and the workflow are all ready. The only thing that's remaining is to give the workflow the inputs that it needs. And for doing that, we have to select the option here, run workflows with inputs defined by data table. We select this one because we have already prepared a data table. And then we have to select the table here. The name of the table, since we have only one table named sample, we select this one, and then we select data. By select data, it means select a row. We have only one row. We select it, and now we have to fill the input attributes here. But before showing you how to do this, let me go through the script and the main WDL file, give you a brief description. You can see that here's the input section of the workflow. It needs child ID, parental, maternal ID, and hi-fi reads, paternal and maternal Illumina needs. They are all consistent with what I showed you in this slide. And there are also some optional inputs that are shown with a question mark. I'll skip it for now. You also see some runtime configuration attributes like thread count or memory size. These are actually showing the size of the virtual machine that Google Cloud Platform dedicates to your job. And you can also select preemptible, which means that there are some preemptible machines on Google Cloud Platform that are less expensive than usual machines, but they are prone to be interrupted in the middle of the job. Now you can also see the calls, the tasks that are being called here. The YAC is being called 2 times, one for paternal and one for maternal data. And you can see hi-fism is being called here, GFA tools. As you can see, they're all consistent with the chart that I showed you in the slide. And this is the list of outputs. The 2 important outputs are the fast-off files of paternal and maternal assemblies. And there are also some other outputs like the output of YAC, the GFA files that hi-fism outputs, and some binary files that we skip for now explaining it. But as you know, the most important outputs are these 2 that we're interested in. So let's go back to the inputs section. Here you have to fill these attribute blank spaces. This is pretty consistent with this script. You can see the child ID here and also here. So now I have to give the workflow the child ID. If I look back to the data table, you can see that the child ID is same as the sample ID here. So the column that I have to mention here is sample ID. By writing this dot, I mean this table. So it looks at this table and find the sample ID table and sync this column with the input that the workflow needs. And this is pretty similar with other inputs. For example, here it needs child reads hi-fi. So I pass the input hi-fi column of this table to for this input. So I write this dot input underline hi-fi. and so on. And you can fill all the attributes like this. But in the output, in the outputs part, you have to write the column that you want to create for each output. For example, here it outputs binary files. Then I write here this dot output underline binary files underline Terra GZ. And this means that create a column if it doesn't exist. Create a column with this name and put the link of this output under this column. And this is all similar with other attributes, other output attributes. And they're all preloaded here. There's nothing that you have to do for now, but you can modify it for other kind of data or other kind of table that you have. So now the only thing that's remaining is to click on Run Analysis. I click on Run Analysis, and then you have to enter some comment is optional here, and then click on Launch. Now here you can see that this job is actually being run here. It is queued, and you have to wait a few minutes, so it will start running the job. But you can go back to the original workspace and see that there exists an already done submission for this workflow. You can click on Submission here, and you can see that it's done. And if you go back to your table, you can see the output columns that appears here. And you are able to download each of the output files that you need. For example, I can download the maternal assembly in FAST.gz format here. Just click on download or use the terminal command. Thank you so much for your attention. I hope that was useful for you.